In the last weeks we have studied kinematics, which is a simple set of equations that describes particular kinds of motion, like uniformly accelerated, uniform motion, etc. What we're about to begin is to study the causes of motion. It is the answer to the question of why an object moves the way it does. Now, people who have no background in physics, or maybe they have studied for a little bit, uh, they have lots of misconceptions about forces and motion. Many of these incorrect ideas can be traced actually back to Aristotle more than 2,000 years ago. Let me discuss some of those ideas and then I'll show you why they're wrong. Suppose that you throw a ball up in the air, just like this little guy is going to do it. So the ball goes up and then it goes down, right? So this question of why does the ball go up and why does the ball go down is a very old question and a very hard one to answer. Aristotle thought about this problem and he concluded that he came up with the idea that objects had natural ways of moving, that depending on the composition of an object, and there were about 5 different kinds of stuff that could make up an object, depending on the amount of each one of these 5 elements that an object had, then this object had a proper place in the universe, a place where it liked to be. For example, if you made a ball of smoke, right, maybe coming out of your pipe, then we know that the ball of smoke is going to go up. Aristotle would say that this ball of smoke was moving in a natural way because smoke was mostly made of air, and since air is up here in the above the ground, then the natural motion for the air is for the ball of smoke, which is made of air, is to move up to join the rest of the air. When you drop a stone, since a stone is made mostly of the element earth, and the element earth is down here, then the stone's natural motion is to go down to join the rest of the earth. So the ball of smoke, when it moves up, is moving in a natural way. It's following its natural motion. When the stone is falling down, it's following its natural motion. This idea, of course, could be used to explain why the ball falls down. After it reaches the maximum height, it falls down. But it doesn't really help you explain why the ball goes up in the first place. The upward motion of the ball is not natural. The ball should be moving at all times, should be trying to seek the earth. So as the ball climbs up, that motion is not natural. And the question then is, why does it go up? So what did Aristotle do about the upward motion? Well, he thought hard about this, and he thought that a solution, a possibility, was to assume that as the ball is moving up, and there is air everywhere, the ball is leaving a vacuum of air behind it, a place in space where there is less air. And since nature does not like vacuum, then the air molecules the air rushes to fill in the vacuum left behind the ball, and that motion of the air ends up pushing the ball upwards. And that's what explains why the ball can move upwards at the beginning in a non-natural way. In the Middle Ages, the upward motion of the ball was explained by saying that when the person pushes the ball up, it gives the ball, in this case, something called impetus, which is sort of an invisible substance that when an object is full of it, the object experiences a force in a particular direction. The object is propelled to move in a particular direction. As the ball moves up, this impetus runs out as if it was some sort of fuel that the ball is using to be able to move upwards. When it runs out of this juice at the top of the trajectory, then the ball has no choice but to follow its natural motion, which is towards the earth. So this was sort of a way to go around the problem of natural motion that was given in the Middle Ages. This somehow actually matches the idea of the way people think about motion and force, people who have no training in physics. Now, ingrained in this idea, in this explanation, is the belief that for an object to be able to move, it requires a force. That for the ball to move up, there has to be a force that is making the ball move up. This is a very intuitive idea, but also a very wrong idea. Galileo was the first one to show that this idea, Aristotelian idea of motion and force, is wrong. But where does this idea come from? Well, this idea comes from our everyday experience, which tells us that in order to make an object move, we have to apply force to it, and that as soon as the force is gone, the object eventually will slow down and stop. For an object to be able to move, it requires a force. This is a very intuitive idea, one that is based in our everyday experience with the motion of objects. Galileo was not the first one to criticize Aristotle's ideas, but he was definitely the first one to do it in a powerful, convincing, and in a actually quite popular way. If you would like to find out more about how he did it, Google Simplicio dialogue. So what did Galileo do? Well, what he did was do experiments. Instead of sitting on a chair thinking about problems, Galileo actually thought that the only way to arrive at truth about nature is to actually do experiments, interrogate nature in a proper way to see what answers nature gives you back. So here's what Galileo did. He did experiments with an inclined plane, a block, and a flat surface, horizontal flat surface. He started with a rough surface and he let the block slide and measure how much did the block move on the horizontal surface before it stopped, before it came to a complete stop. So then he wondered what would happen if he polished the horizontal surface a little bit more. He did that. He measured now what was the distance that the block traveled until it came to a complete stop, and he found that that distance was greater than before. He polished the surface a little bit more, and he found once more that the block moved a distance bigger than the distance that it traveled on a rougher surface. So at this point, Galileo has his great idea about motion and force. He concludes that if he were able to polish the surface so perfectly that there would be no friction, no rubbing between the block and the horizontal surface, then the block would never stop. The distance that the block would travel before it came to a complete stop would grow and grow and grow as he approached this limit with no friction, and until the block simply would just not stop. In this limit, when he has eliminated all forces acting on the block moves with constant velocity. The velocity would not decrease, it would not increase, of course, so that means that it will remain constant. So Galileo has his breakthrough, which is to realize that if you could get rid of the forces acting on an object, in this case friction, then the object would move with constant velocity. This contradicts Aristotelian's idea about force being needed to produce motion. For Aristotle, every time an object is moving, there is a force that must be acting on that object to keep it moving. Galileo realized that this was just not true. In fact, the opposite was true. A force is required to make an object come to a stop, to change its velocity. For an object to continue moving with constant velocity, no force is necessary. In the absence of force, the velocity will remain constant. So Galileo clearly didn't have the means to reduce the friction in his inclined planes to a small value, to zero, but we do have nowadays the ways to do that. Simplest, most popular way to do that is with an air track. An air track, which is a device that you can see here, it's a metal pipe, a hollow metal pipe, where you pump in air inside, and there's little holes on the surface out of which the air can come out. The rider, which is the piece that is going to move, is just simply a piece of metal. It's folded in the middle, so that it can ride on top of the air track. And because of the air coming out of the little holes on the air track, then the air is preventing, that stream of air is preventing the rider from settling on the air track. So basically there is no physical contact between the rider and the air track. So this reduces friction between the rider and the air track to basically zero, and the only force that opposes the motion of the rider is air drag, the contact between the rider and the air underneath and on top of it. But this is a very small amount. So you can see, as you've seen before in the videos for one-dimensional motion, that the motion of a rider, an object like this, is constant velocity. There is no evidence that the velocity is slowing down. Here we send the rider with a different, smaller velocity. You can see that it keeps going and going and going without any sign of slowing down. So to the Aristotelian question of what keeps the ball moving up, Galileo would say that this was the wrong kind of question, because this question is assuming that for an object to move up, it needs a force to keep it moving up. According to what Galileo discovered, the tendency, the natural tendency of the ball after you let go of it, after you left it moving with a velocity that is going up, the natural tendency of the ball would be to continue to move up. Then Galileo would ask the question, what prevents the ball from continuing to move up forever? So the question is not what makes the ball move up, but better, what prevents the ball from continuing to move up forever? The answer to this question was given by Newton, and the answer is the force of gravity. After the person has let go of the ball is moving upwards with some velocity. The ball would like to keep moving with that velocity, but there is a force that starts acting on the ball, which is the attraction between the ball and the earth. The earth puts a force on the ball that is downwards, and that downward force is what prevents the ball from continuing to move up forever and to leave the earth and move into outer space. It is the force of gravity that brings the ball to a stop. Now at this point, after the ball has reached a stop, the force of gravity does not disappear, it does not increase or decrease, it continues to be acting on the ball, and this is the same force that now makes the ball move down towards the earth. So there is no two different kinds of forces acting on the ball at different times when it goes up and when it goes down. It is the same force that is responsible for the particular way in which the ball moves up and for the particular way in which the ball moves down. So what Galileo is telling us is that a force is required only when we're interested in changing the state of motion of an object, when we're interested in changing its velocity.